and welcome to Chem Talk, where today we will be going over factors that affect the solubility of compounds, as well as how it is relevant to the development of drugs in the pharmaceutical field. As always, let's begin with some definitions. There aren't too many this time. Let's start with solubility, which is the ability of a substance to dissolve in a solvent, thus forming a solution. Then we can just simply define a solution as a mixture in which forces within the solute have been overcome and a homogeneous mixture is formed. Finally, because I will mention it a few times over the course of the video, a solute is what is being dissolved, and a solvent is what the solute is being dissolved into. Both of these combined create a solution. Now I'll list off some of the major factors that impact solubility. 1. Temperature. 2. Surface area. 3. Physical state, like liquid, gas, solid. And 4. Electronegativity. So let's take a little dive into each one, starting with temperature. Let's say you have a sugar cube that you have placed into a beaker of water. These sugar molecules are held together by intermolecular forces, which will be explained in more detail in another video. As you allow the sugar cube to sit in the water molecules will eventually wriggle in between the sugar molecules and help separate them. However, if you add heat to the beaker, this process will occur significantly faster. By adding heat, you are adding energy to the beaker, and in order to break any kind of bond or attractive force between two things, energy must be added. The heat helps the sugar molecules overcome their intermolecular forces, which allow them to disperse and dissolve into the water. Now let's cover surface area. As water molecules surround a compound, their polar ends exert an attractive force on the solute's molecules, pulling them away from one another and allowing them to spread out among the water molecules. Therefore, the more surface area of a solute that is exposed, the faster it dissolves. Additionally, more water molecules bumping into the solute help break it apart faster. One way you can increase the surface area of a solute is by breaking it up into tiny pieces before placing it into the solvent. Once this is done, a much larger surface area of the solute is exposed to the water and it will dissolve faster. Now let's go over physical state. As you likely may already know, states of matter are caused by the degree of attraction and kinetic energy between particles. In a solid, the kinetic energy of the molecules is low enough that the attractive forces are able to keep the molecules packed tightly together. In a liquid, the energy of the molecules is higher, meaning they are able to move a little more freely and are less bound by the attractive forces. Finally, in a gas molecule, they have so much kinetic energy they are able to completely overcome attractive forces and move about freely. That's why it takes much more energy to take a liquid to a gas versus solid to liquid. Because gas molecules are less bound by attraction, they can sometimes be more soluble than solids. But the higher the pressure is on a gas, the more soluble it is. This is because sometimes a gas is too free-moving to want to dissolve into a solvent, and pressure helps compact the gas molecules slightly. Now let's discuss electronegativity and overall polarity. We've discussed attractive forces throughout this whole video, and now we can delve a little deeper into one specific one, which is the electronegativity of atoms in ionic and covalent bonds. The solubility is actually dependent on both the solute and the solvent. With ionic compounds, when they bond, a positive and negative end is formed, and they have what is considered a very high polarity. We can take sodium chloride as an example. If the compound is then placed in a solvent that also has a high polarity, H2O works, then it will be very soluble. This is because the negative ends of the ionic compound will be attracted to the positive ends of the solute and vice versa. In a covalently bonded compound with a low polarity, let's say CH4, they will be most soluble in a nonpolar solvent. Basically, the more similar the solute and solvent are in polarity, the more soluble the solute will be. Solubility has a big connection to medicine. For drug medications, solubility is a big factor in understanding how and how quickly they work. For one thing, the more soluble a drug is, the faster it can be broken down and uptaken into the bloodstream. The faster this occurs, the sooner the person who took the medicine will begin experiencing its effects. Additionally, a drug's solubility in water is very similar to its lipophilicity. This is something's ability to be taken up by cells, bind to proteins, and thus become effective. Because of this, a lot of time is spent by pharmaceutical companies to ensure that any new medication or drugs are soluble in water, as this confirms that it will also dissolve into the bloodstream in the body and increase the bioavailability of the drug in the body system. Now for a quick summary. Let's go over some of the different factors that can affect solubility one more time. We have temperature. A higher temperature adds energy to the molecules, allowing them to separate from one another easier. A higher surface area allows the water molecules to collide with the solute more frequently, leading to it breaking apart faster and ultimately dissolving. The physical state of a solute affects how soluble it is. Solids have significantly less energy, so they will need more mixing or heat to dissolve compared to a liquid gas. The physical state of a solute affects how soluble it is. Solids have significantly less energy, so they will need more mixing or heat to dissolve compared to a liquid. Gases, on the other hand, move so freely that pressure is often used to get them to compact and dissolve into a solute. The electronegativity of individual atoms in a molecule, or the overall polarity of a molecule, also impacts how soluble it is. Nonpolar substances dissolve best in nonpolar solutes, and polar solvents dissolve best in polar solutes. Remember, like dissolves like. So that's all for today on factors that affect solubility. Thank you for tuning into ChemTalk. Make sure to visit our website, www.chemistrytalk.org, for hundreds of general, organic, and biochemistry articles.